Hello all, in this video I am going to demonstrate the project which is used to monitor patient-client reports remotely. In this, we are using AWS IoT to connect patients and doctors and providing them a platform which always stays connected to each other by real-time tracking of patient health data. A device is configured for the patient, and that device which is with the patient allows to monitor patient ECG, blood pressure, HR and many other concerns. Like you can see on the doctor's dashboard, here is the heart rate, mean, blood pressure, blood oxygen level, respiration rate and event reports over here. Below that, you will be able to see the live data. Here you can see ECG data. Let me show you. This is the ECG live data of the patient. Below that, we have heart rate live data of the patient. You can also filter the data with last 2 hours data, 4 hours data, 8 hours, 12, 24, etc. You can see heart rate variation data below that. It is live data, so the data is continuously changing. As you can see the changes in the graph. You have blood pressure live data, blood oxygen level live data, respiratory rate data, physical activity, body temperature data. So basically on UI, doctor can monitor live data of the patient health in the form of reports and graphs in the system, which consist of active readings in real time, or can say that the actual readings in real time. Now here you can check the hardware device data on the IoT core console. This is the device data, so the device data is pulled and can be seen over here. This is actual device data which has been pulled and shown over here.
This is the device which is used to monitor patient health, and this device is configured at the backend by admin to measure the patient health. A threshold value is set for each health concern, and if any of the threshold value increase or decrease for any cause, the respective doctor get notified or informed via email that the patient has been affected.
Now let me show you the architecture diagram. So this is the architecture diagram. We have used AWS IoT Greengrass for designing interface. Using this, we created group, core, device. By clubbing them, we deployed them on each device using AWS Greengrass. AWS Greengrass core. We have used this to communicate, and if the AWS IoT Greengrass core devices loses connectivity to the cloud, connected devices can continue to communicate to each other over the local network. We have used AWS Lambda functions. So basically, we have used AWS Lambda functions to perform operational and administrative activities, including provisioning capacity, monitoring health, applying security patches, deploying code, and monitoring the logging Lambda functions. The data which is received at runtime in topic is managed by this Lambda function, where we have written logic in our system which is responsible for decision making. So these were the main components of our architecture diagram. So let me explain you this in a little depth. Here we have mapped the hardware serial port through computer to C data. So you can see the data is updating continuously over here, which is coming from the device as this is mapped with the device. Now we have implemented POSIX queue through which data is collected at central module and that data is published in topic. So all sensors send signal using AWS Greengrass SDK, and this is done using MQTT messaging queue. So the data travels from AWS Greengrass to IoT core. Here you can see the payloads. Here you can see the payloads. This is the heart rate payload and the data which is updating as per data receiving on device, and this data can be seen here on the web portal. So you can see, so let me show you the data. So here you can see the min and max as 110 and 57. So this is 110 and 57. Now the data will get updated. Here now you can see the maximum 159 and 102. 159 and 102, the data has been updated. So this way the data is managed and tracked